Okay, folks, today's topic is polar coordinate graphing system. So we're used to the graphing system X and Y, but we've changed these axes. So this axis is now the R axis, so that's the radius. And then what we do is we take that axis and we're going to rotate it some degrees or some radians around the unit circle. So this is, instead of using X and Y, we do the radius and rotation around the unit circle. So let's pick an example. Make more sense when you see an example, I think. So 2 comma pi over 3. So this is how far I am away from the origin, and this is at what angle or rotation around the unit circle I've moved. So I'm going to take this axis and I'm going to basically rotate it up until pi over 3. Remember, pi over 3 is 60 degrees, so that would be right here. So now I'm going to take this and I'm going to rotate it up to there, and then from the origin I'm going to go a distance or a radius of 2. So 1, 2, that would take me right here. That would be considered the point A. I went a rotation of pi over 3, and I went a distance or a radius from the origin of 2. Try another one. -3, 11 pi over 6. So we're used to, when it's X and Y, we're used to doing the X first and then the Y. When it comes to polar coordinates, it's actually a little bit easier to do the rotation first and then do the radius. So remember, you're going to always take the kind of the positive X spot. You're going to take that, you're going to rotate it. Remember, 11 pi over 6, I'm counting by 30s. I'm counting 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, of course, if you have your unit circle, feel free to use that too. But remember, I'm taking this positive side and I'm rotating it. So now this is considered the positive x-axis, or the positive radius axis, sorry, and this is the negative. So when you have a negative radius, that means instead of going towards the angle, here's 11 pi over 6, I'm going to go from the origin and I'm going to go the opposite direction, because this is the positive r, so this must be the negative radius. So I go to an angle 11 pi over 6, I use one finger to stay there, then I go back to the origin, and I decide what my radius is. My radius is -3, so instead of going towards my finger, I'm going to go away. There's my point B. Try another one. -1, comma negative pi over 2. Like I said, it's always better to start with the rotation first and then look at the radius. So I'm taking a rotation of negative pi over 2. Remember, negative rotations go this way. Pi over 2 is a 90. So I'm taking this positive radius and I'm rotating it down here. So these are the positive radii. These are the negative radii. So now I go back. Here's my angle. Go back to the origin. I want to go a radius of -1. So instead of going towards my marker or my angle, I'm going to go away because it's negative. And so now this is a distance of C. All right, so I'm going to do the next 3, but I would recommend that you try to take and do this on your own first. Sorry, Miss Chesney just stopped by. I don't know where I left off. So anyway, the next 4, I'm going to encourage you to try to do on your own first by hitting the pause button after I write down the coordinates of the polar coordinates. Yeah, so next one is -1, my bad, -3, 3 pi over 4. Pause and try that on your own. Okay, so my rotation is 3 pi over 4. Remember, that's 45s. I'm counting off 3 45s. 1, 2, 3 45s. I like to leave my finger at the angle. Now, if your radius is positive, you go from the origin towards your angle or towards your finger. If it's negative, you go the opposite way. So 1, 2, -3. That would be D. I would encourage you to pause after this one and try it on your own. The point E is 2, -5 pi over 6. Pause, try it. All right, I'm counting by pi over 6s, so that means I'm counting by 30s. I'm going negative though. So 1, 2, 3, 4, -5. Leave your finger at the angle. This time my radius is a +2, so I want to go towards the angle or towards my finger. So there's the point E. Give yourself an elbow bump if you did a good job. All right, let's get a little bit tricky. 2.5, comma, negative 100 degrees. Pause it. Estimate, obviously, but pause it and try it on your own. Okay, so I'm going to have to estimate where negative 100 is. I don't know. There's negative 90. There's negative 100, whatever. 2.5, I want to go towards the angle. So 1, 2, let's call it right here. Yeah, good enough. F. I know this is hopefully getting to the spot where you really get it. Kind of feels like it's repetitive, but that's okay. This is the last one that we're going to do in this section. So the point is negative 2, comma, negative 2 pi over 3. Pause, give it a try. All right, let's see how you did. So I'm counting by 60s. I'm going negative 2 60s, so negative 1, negative 2 60s. Okay, this is my angle. I've got a negative radius. This would be going towards it, so I want to go the opposite way. OMG, it's the exact same point. Okay, and so that leads us into the next topic, the next section, which is find multiple representations of the given polar coordinate pair. So this is an example. A and G are an example of multiple representations of the exact same point. Let's take a look at what that looks like. So I'm going to give us an angle, and then we're going to use that angle to try to figure out all the different ways we could write up that location. So our first angle, our first coordinates are 3, negative 3 pi over 4. All right, so pause it, try to graph this on your own. Let's see how you did. On 45s, I'm going negative 3, negative 1, negative 2, negative 3. That's the positive side, so I want to go in that direction. So this is where A is. Okay, so look at our rotations. We've got a rotation of negative 3 pi over 4. Let's go to that same place, but go the opposite way. So instead of going to negative 3 pi over 4, I'm still going to count by 45s, but I'm going to go in the positive direction. So that's positive 1, positive 2, positive 3, positive 4. This is the same as 5 pi over 4. So the angle, the rotation, of negative 3 pi over 4 is the same as the rotation of 5 pi over 4. Now we've got to decide if we want a positive or a negative here. So 5 pi over 4 takes me here. This is where I want to end up. So from the origin, I need to go positive 3. I want to go towards that angle. Okay, so we've gone to this location this way, and we've gone to this location this way. There's no other way to get here on the rotation, but what we can do is rotate directly across from it and then use a negative radius. So let's figure out, first of all, the rotation that takes us across from this. So that would be a rotation of pi over 4. Now, here's my angle, pi over 4. Here's the origin. That's where I want to end up. So what kind of radius would I need to be able, I don't want to go this way, I want to go this way. So my radius would have to end up being a negative 3. Okay, so just to recap, we went this way and this way. So we rotated to the location of the point. Then we rotated positively across from the point. Now we're going to rotate negatively. So I want to go here twice. And then I want to go here twice. I don't really want to label that as a point. I'll just write a check mark to indicate that's a location that's helpful. All right, so we rotated positively across from it. Now we're going to rotate negatively. So that's negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7 pi over 4. All right, so negative 7 pi over 4 takes me here. This is the origin. So what kind of radius? I don't want to end up here. I want to end up at A, at our point. So I don't want to go towards the angle. I want to go away, which means I need another negative radius. So a couple things to notice. Half of your radii will be positive, the other half will be negative. And then your rotations are always, you pick where the point is and you go towards it positively and towards it negatively, and then across from it positively and negatively. All right, here's yours. You are going to try to do the point 2, comma 2 pi over 3. First of all, you got to figure out where that is. Pause, figure out where that is. Okay, unpause. Hopefully you've unpaused and figured out that we're counting by 60s. We're going 2 of them. So there's my angle. Here's my rotation. There's my origin. I'm going towards it, a positive 2. So there's the location of the point B. All right, pause again and try to figure out the other 3 different ways that you could get to the point B. All right, let's see how you did. So I go towards it twice. From the positive side is what they already gave us, so I can't use that one. So let's go to this rotation negatively. I'm counting by 60s. 1, 2, 3, negative 4 pi over 3. Okay, negative 4 pi over 3 took us here. There's the origin. Is the point on the way to the angle or away? It's on the way. So I want to use a positive radius again. So we've gone to the rotation positively and negatively. Now we're going to go across from that. So I'm going to rotate positively directly across from here. So that's, first of all, I'm counting by 60s. 1, 2, 3, 4. That's 5 pi over 6. My bad, 5 pi over 3. Okay, so here's the angle. There's the point. There's the origin. So from the origin, if I want to hit that point, I don't want to go towards the angle. I want to go away, which means I need a negative radius. So we rotated positively here, negatively there. We rotated positively here. Now we need to rotate negatively there. So that's negative pi over 3. Negative pi over 3 is here. The origin is there. I want to go away from my angle, which means I need a negative radius. How did you do? If you did a good job, give yourself an elbow bump. All right, so I'm going to stop here, and then we'll do the back side in another video.